This is lesson 10.4.
Talking about inscribed angles. So an inscribed angle has its vertex on the circle. Okay, so not on the center on the center of the circle. It's actually on the circle itself. So while the center help forms the circle, it doesn't count as part of the circle. It's not on the circle anyway. And its sides are chords on the circle. Whoop! It decided to just jump away from me. Okay. Its sides are chords. So angle ABC in this picture here is the inscribed angle. So it's inscribed because its vertex is a point on the circle, and then its sides are chords. The measure of the inscribed angle ABC in the figure is 58 degrees. So you can measure it, but it's supposed to be 58 degrees anywho. And then the intercepted arc in the figure is arc AC. So intercepted arc meaning that's the arc that the two sides that are formed and the two endpoints of the chords form an arc. Okay, that's our intercepted arc. So it's like if you were to extend those two lines, it's the arc that would be cut off from drawing that angle. Okay, so the intercepted arc in the figure is arc AC, and its measure is 116 degrees. Do you see a relationship here? Okay, so 116 degrees. So that's, CHA or AHC, because the measure of the arc is the central angle. So obviously, it's double the inscribed angle, or you would say that the inscribed angle is half the measure of its intercepted arc. And notice they're not the same angle, because if you extend this guy for CB, BC and CA, if you extend that, that's the angle, that's the 58 degree angle. And then if you extend this guy, that's why it's the wider angle. And so that guy, try one more time. This guy is the 116 degrees. All right, moving on. The measure of the inscribed angle in this next one, angle CBA, is 58 degrees. So CBA the measure of the inscribed angle CKA, so notice that's another inscribed angle. That's another chord with the same endpoints C and A, but to a different point on the circle. That one is 58 degrees. So both inscribed angles intercept the same arc named AC. There's 58 degrees. So both inscribed angles intercept the same arc named AC. And the reason they do that is because they share the endpoints A and C for the sides. So K and B are different, but they both, to form the sides of the angle, the inscribed angle, have the same endpoints C and A. So if two inscribed angles intercept the same arc, then the angles are congruent. So we kind of went backwards first. We started out with congruent angles, showed that they were going to intercept the same arc, and then said that if that happens, so if they intercept the same arc, they're going to be congruent angles. So I could do another one. I could put another point on the circle and call it L, okay, and draw to draw that inscribed angle. So I'm going to connect a chord from C to L and L to A. So again, I'm using those same endpoints on the circle to make chords. Then that angle will also be 58 degrees. So there's a cool thing that I could show you on Geometry Sketchpad, that if I just move this angle, this point L, wherever I want to, and keep the endpoints as C and A to form the sides, two sides of the angle, it will always be 58 degrees no matter where you put it. It's kind of cool. Okay, then there's some problems over that, but on the back page there's more notes. So let's go to the back. But, oh yikers. What did it do to me? Okay, so we're still talking about inscribed angles. So if an inscribed angle intercepts a semicircle, then the measure of the inscribed angle is 90 degrees. Okay, so the two endpoints are on a diameter essentially, because the diameter will mark off a semicircle. So if you have a point anywhere on the circle and it forms an inscribed angle where the chord has an endpoint, has endpoints that form a diameter, then it's going to intercept a semicircle, which means the inscribed angle is 90 degrees. And that's because, remember, on the previous page, we said that the intercepted arc, so if two inscribed angles, well, I'm sorry, so if the intercepted arc is always going to be double the inscribed angle, or the inscribed angle is always half the measure of the intercepted arc. So the intercepted arc, which is WTZ, okay, we'd have to call it the major arc WTZ, which is a semicircle, then that's 180 degrees. So the inscribed angle is half of that, so it's 90 degrees. So anytime you've got a point anywhere in the circle where it forms an inscribed angle and the endpoints are chords, and that whose endpoints form a diameter, then that's going to intercept the arc, therefore be 90 degrees. So if an inscribed angle's measure is 90 degrees, so this is going the other way, if you know an inscribed angle's measure is 90 degrees, then it cuts off a semicircle. So it intercepts a semicircle. So this is our backwards and forwards, so you know what's coming, an if and only if statement. So an inscribed angle, oh my lord, inscribed angle, just totally messed up my letters there, intercepts a semicircle. An inscribed angle intercepts a semicircle if and only if the measure of the inscribed angle is 90 degrees. 90 degrees, okay? So again, if we have any inscribed angle, 90 degrees, well, then it must intercept an arc. Therefore, the endpoints of the two sides, so for the chords that it form a diameter. Sorry, my words are kind of just like all over the place here. So next part, if a quadrilateral is inscribed in a circle, interesting. Then we've got some things that happen. So what I want you guys to do is actually draw any quadrilateral you want in this circle. And I want you to measure each of its angles, okay? So my Apple Pencil is temporarily out of order here. So we're going to zoom in and do some things here. All right, so I'm just going to draw, wow, okay, 4 random points. Let's see if we got a little juice here. Okay, yes. Okay, 4 random points here. Anywhere you want to form a quadrilateral, and then use a straight edge to connect them, and then measure their angles. So I'm going to turn this off while I do this. Okay, forgive my not straight lines. So if you just draw any quadrilateral you want where each of the vertices is on the circle, then measure the angles. And what you should notice is that opposite angles are supplementary. So say this angle up here, it looks like 100 degrees. Then this one would be 80 degrees. And this one looks like, well, it kind of looks like 100 again. So we'll say 115 degrees. So this one would be 65 degrees. So that will be true for all of your quadrilaterals, even though you guys, there's no way you made the same exact one unless you tried to make it 90 degrees or whatnot. So if a quadrilateral is inscribed in a circle, then sorry, my thing's going crazy. Then the opposite angles are supplementary. All right, and then there's some problems for you to work out there. So I'll let you work them out and I'll post a key and you should be good. Thanks for watching.